The next thing we want to talk about is kind of the architecture behind Asterisk. We want to talk about some of the major components, the structures within Asterisk. Talk about some of the user interfaces, both interfaces that you as an end user might use, as well as some programmatic interfaces that other programs can use to interact with an Asterisk system. I'll talk about where does Asterisk stick its files within the Linux file system. I'll talk a little bit about the configuration methods for configuring Asterisk, and then talk about kind of the 5 most important configuration files. We're going to start to dive into the configuration files and understand them a little bit more. First of all, from a purely architectural standpoint, remember that Asterisk starts out as just being software. And that software is going to run primarily on Linux, but you can run it on BSD, or you can run it on Solaris, or you can even run it on OS X if you want to. Anything that's a Unix-based operating system. Some of the hardware drivers, though, were for, say, the analog cards or the T1 cards, those sorts of things, were created for Linux. And so they often don't have equivalent drivers, or the drivers aren't quite up to speed in some of these other operating systems. So if you're not sure, well, should I deploy it on BSD? Should I deploy it on Solaris? Should I deploy it on Linux? If you're unsure, go pick your favorite Linux distribution and deploy it on your favorite version of Linux. Okay. Now, if you don't get anything else, oh, we have a question over here.
Okay, you're talking about what version of Unix or Unix-like operating system. Take Fritzbox, for example, runs on CentOS, which is basically a bastardized version of Red Hat. You were just saying that well, you could compile it to any operating system that you're comfortable with. But really?
Really, if you're comfortable with building your own Linux distribution and running on that, run it on whatever you're comfortable with. If you want a supported operating system that you can go to somebody and get support on when you need help, then go buy a Red Hat or a Okay. So run it on FreeBSD if that's what you're comfortable with.
This operating system or this application.
Sorry, what's that? Sure.
Did I skip? I'm sorry if I. I mean, question and answer. Sorry.
That's all right. We'll make sure we leave plenty of time for questions and answers.
It's just that when you said that, I'm just like, well, wait a minute, hold on a second, because I'm thinking of the way Asterisk is deployed. It's very specific to the operating system, and you were just saying
it's not that specific to the operating system. It runs just fine on BSD. It runs just fine on Solaris. It runs even on OS X. It runs just fine. It doesn't run well in Windows. Yes. There it's running right there on an Apple box. How about that? Yes. Yes. It'll run just fine. Okay. The more important thing that I want you to understand is this picture right here. Okay. This picture kind of sets out the map for the architecture of how the different pieces of Asterisk work together. Okay? Across the top, we have some blue boxes. Across the top of this picture, I have what we call channel drivers. Channel drivers are pieces of Asterisk that go out and talk to the outside world using a particular protocol. So you see I've got a SIP channel driver up there, for example. That's the piece of Asterisk that talks SIP to the outside world and converts that into something that the core of Asterisk can understand. We've got a channel driver up there called DOTI. DOTI is the Digium Asterisk Hardware Device Interface. Nice name. That's what talks to analog cards, T1 cards, kind of traditional telephony cards. The other channel drivers up there, EEX2 and H323, those are other voice over IP protocols that Asterisk knows how to talk. Across the bottom of this picture, we have what we call drivers and converters. These are tools that Asterisk uses to either write out some kind of records. And so like our CDR drivers are call detail records. That's how it writes out a log of what calls have been made on the system, by who, and how long did they last, those sorts of things. There's drivers for different audio and video, what we call codecs. These are the mathematical algorithms for shrinking down the audio or the video so it takes up less bandwidth. There's file format drivers that knows how to read files from disk, write files out to disk. And then there's system configuration drivers. Drivers for saying, hey, how am I configured? What SIP devices am I supposed to talk to? What analog devices am I supposed to talk to? Those sorts of things. Those all feed into what we call the core of Asterisk. The core takes care of loading the other modules, taking care of talking to the channel drivers. And the biggest piece of the core is something we call the dial plan. The dial plan is really the scripting engine within Asterisk. It's where you put all your logic in the system. It's where you say, hey, if somebody dials extension 123, what's going to happen? Okay. Now on a traditional PBX, that's just a simple routing table, right? It's like, well, 123 goes here, and 124 goes here, and 125 goes there. In Asterisk, it really is more of a scripting engine. You know, if you dial extension 123, you can say, well, check the internet and check the stock price of Red Hat, and if Red Hat's over $40 a share, and the temperature outside is above 32 degrees, then I want to route the call this way. Otherwise, route the call this other way, or stick them in a call queue, or place them on hold indefinitely. Whatever the case may be, you have all the logic to be able to script that any way you want. So it's much more free form than a traditional PBX. Now the dial plan there calls on a couple of different things. It calls on applications and resources. Applications are things that happen sequentially during a call. So it's like answer the ringing line, play this sound prompt, start recording the call, play this IVR menu, send the caller to voicemail, hang up the call. Those sorts of things. Those are applications. And we'll get into some sample applications here in a few minutes. The dial plan also, like I said, calls on resources. Resources are things that are used asynchronously, not just sequentially one after the other, but in the middle of a call. Things like putting a call on hold, or putting a call on into a parking lot, or playing hold music, or call transfers. These sorts of things that happen in the middle of a call use resources within the Asterisk system. Last but not least, I've got the two yellow boxes there that I want to highlight there in the core. The one on the left is a command line interface. So anybody who's familiar with Unix or Linux knows we have to have a command line interface for the administrator to go in and see what's going on and watch the calls that are flowing by and those sorts of things. We also have a programmatic interface called the Asterisk Manager Interface, or AMI, shown over there on the right-hand side. This is an API that external programs can use to interact with Asterisk and say, hey, Asterisk, what calls are going on the system? Or, hey, Asterisk, call Jamie, and when he answers the call, play this prank sound file. Tell him his phone system's been eaten by iguanas or something like that. Whatever you want to do. It's an external API that external programs can talk to Asterisk and kind of do command and control of an Asterisk system, which is very, very friendly. I wish every PBX out there had those sorts of things. But that's kind of the big picture of the architecture of Asterisk. It's a set of these different modules that you can load up and use in various ways to drive whatever it is you're trying to build out of the PBX, whether it's a phone system or a VoIP gateway or a call center application, whatever it is you're building, you're going to mix and match these modules to talk in various different ways. Okay, let's talk in a little more depth in each of the pieces of this picture, and then we'll come back and start diving into the configuration. First of all, like I said, the core is kind of the heart of Asterisk. It loads up all the other modules. It provides timing. It reads the configuration files. It's what takes care of processing the calls, answering the call, playing back sound files, hanging up the calls, those sorts of things. And then converting the different protocols so that they can talk with each other. Okay? So it's really the heart of the system. Now, like I said, everything else in Asterisk is just loadable modules. So the channel drivers are all modules. The file format drivers are all modules. The CDR drivers are all modules. Everything else is a module. And each of these modules might provide a channel driver or an application or a resource or a combination of those. And you as the Asterisk administrator get to choose which modules get loaded up. By default, Asterisk is going to load up all the modules it can find. So again, it's 150 something different modules last time I checked. Okay, if you're building a very specific, Asterisk system for like a very niche market, you may only need 5 or 6 of those modules. Let's say you're building an Asterisk system that fits on a little embedded PC that lives inside some sort of embedded environment. Let's say you're putting it on a ship out in the middle of the sea, and you just want these two systems to be able to talk to each other, and Asterisk is just converting between a couple of different formats so that two disparate systems can communicate with each other. Maybe you've got a telephone system and a radio system, and you want them to talk to each other. You may only need 5 or 10 modules to get that particular piece working. You may not need things like voicemail and auto attendance and conference calling. That make sense? So you as the administrator get to choose what is it that I'm trying to accomplish with this system. Okay? Now, let's talk a little bit more about the configuration. By default, Asterisk gets all its configuration from a set of just plain text files. Okay? Now, you can augment that with something we call ARA, or the Asterisk real-time architecture, where instead of looking at text files, Asterisk is going out and querying, say, a relational database or an LDAP directory or some other structure out there across the network to say, hey, what do I do next? What configuration should I have? This comes into play, especially if you've, say, got a large number of Asterisk systems and you want to have sort of a centralized configuration for all those different systems. That's really when you want to start looking at the Asterisk real-time architecture, those sorts of things. But for now, let's just start out with the basics. We're going to start off with the plain text config files and start looking at those and how they work. Now, anybody here know how to edit a plain text file? Good. It's pretty easy, right? No special tools. We're not going to sell you, a $300 application to be able to edit the configuration files. It's just a plain text file. Okay? So let's look at what they look like. Now, first of all these configuration files typically live in the /etc/asterisk directory. Now, if you're familiar with Unix and Linux, the /etc directory is usually where your configuration files go. We've got a subdirectory in there for Asterisk. And all of these configuration files are going to have a .conf, a .conf extension to tell you it's a configuration file. Okay? And they are just plain ASCII text files. Use your favorite text editor to edit them. So for the Linux people in the room, how many people here use Emacs? Boo. How many people here use VI? Yay. You always have to have that debate, right? Anytime you get Linux. How many people in here don't know what either VI or Emacs are and don't care? There's probably a few of those too. So use whatever editor you're comfortable with. Now, when we teach this module in the Asterisk classes, we actually simplify some of the Asterisk configuration files to help people get started. And I think that's one of the problems that Asterisk suffers from right now is that the configuration files, kind of the sample configuration files that come with Asterisk, they're great. They've got a lot of detail in there, but they're really overwhelming when you first start looking at them. So I want to kind of take a step back and look at a very, very simple version of each of those configuration files and get you the basics, and then you can go look at the sample configuration file that comes with Asterisk and say, aha, now I understand what that's doing. Okay? Before we dive into the individual configuration files, I want to talk a little bit about kind of the structure of the configuration files themselves. Anybody here use Windows about 10 years ago? I admit I used Windows about 10 years ago. Anybody familiar with like .ini files under Windows? Oh, the pain, I know. So we use that same sort of structure when we build configuration files in Asterisk. Anything that's a section of a configuration file is going to have a section heading, and that's in square brackets. So you see my section heading there. Okay. Underneath the section heading, you're going to have settings, and it's going to be the name of the setting equals and a value. So you can say setting equals true, another setting equals false, password equals 1, 2, 3, 4, 5, whatever the settings happen to be. If you want to put a comment in there, you put a semicolon, and then from the semicolon to the end of the line, that's a comment. Okay. What if you want to have a comment that spans multiple lines? Well, if you put a semicolon, hyphen, hyphen, that starts a block comment, and that block comment is going to continue on all the way down till we get the hyphen, hyphen, semicolon there at the bottom. So if you want a multi-line comment, that's how you would do that. Okay? Not the most advanced configuration file format in the world, but it's very easy and it works.